Right, so today in class we talked a little bit about factoring expressions. We've been talking a lot about GCF lately. That's the greatest common factor. And there's links to all my other videos on GCF. You can find those by looking through my videos. So we're not going to talk about how to do GCF, but we're going to look at how we can use it to break down some factors. So just to start off, this also references the distributive property. So if you remember earlier this year, we looked at something where you could say, for instance, 8 times 3 plus 8 times 2, how you could rewrite that as simply saying 8 times 3 plus 2. So that's the distributive property, and so we're going to be thinking about that a little bit. But what might happen is sometimes you don't start with the multiplication problem. Okay, sometimes you start with simply like 24 plus 32, and you need to go from this, and then to that. So we're looking at how that works. Now this really comes in handy when you're using expressions with variables, but we're going to start with some just regular numbers, and we'll do one with a variable. So we're going to follow kind of this format right here. I'm just going to put this as kind of what we're going to do. So you can see it starts by needing the GCF. So if we started, for example, we'll do this as example 1, with 20 plus 60, and we had to rewrite this by factoring out the greatest common factor. We're going to first find the GCF of these two numbers. Okay, so find the GCF. So I have 20 and 60. You can use any method. Actually, I'm just going to write 60. So I'm not going to write the subtraction symbol there, or the addition symbol. We'll just bring it back at the end. I'm going to find the GCF of those. I'm going to use the cake method, so I can factor out 2, and then I can factor out another 2, and then I can factor out a 5. Right, and so then we would circle sort of these three, and our GCF is 2 times 2 times 5, or our GCF is 20. Okay, so we see GCF equals 20. So now what we're going to do is we're going to take that 20 and we're going to use that with this expression. We're going to use sort of this setup to remind us where to go. So we're going to start by writing something and then a multiplication problem in parentheses. So I'm going to write blank times blank plus blank. Now the reason I have two things and I have a plus is because I have two numbers and a plus. So now I'm going to take my GCF. That's the first thing. That was the base thing. I'm factoring that out. I'm dividing each of these numbers by the GCF. So that's like saying 20 divided by 20. So this first number divided by the GCF. That's going to give us 1. 60 divided by 20. That's going to give us 3. Okay, so this is kind of where these numbers came from. So this means the same thing as this. Now if you've noticed, you'll see that the 1 actually came right down and the 3 came right down. So if you're using the cake method, it's actually pretty quick to transfer that. We're going to look at another example. So this is really, that's your answer for this. That's how you factor out the GCF. Look at another example. Put this to the side. And so we'll call this number 2. And let's say we had 48 minus 30, and we wanted to rewrite that by factoring out the GCF. So I'm going to take 48 and 30 and find the GCF. 48, 30. I'll use the cake method again. That gives me 24 and 15. Factor out 2, and that gives me, I can't do that. I'm at 3. And that gives me 8 and 5. Okay. So I've figured out my GCF. My GCF is 2 times 3, so my GCF is 6. So now I'm going to factor it out. I'm going to use this same method. I'm going to think, okay, GCF first, then the first number divided by that GCF, second number divided by GCF. So I put my line here, and my GCF is going to be 6 times, and then the two parts you can see are the 8. 48 divided by 6 is 8. And then it was subtraction, so I'm going to put a subtraction symbol, and 5 was what 30 divided by 6 is. So this, again, we've just factored out the GCF to just sort of rewrite this expression. Now this is not something you're really going to do that often in math unless the teacher is asking you to or a book's asking you to. But what you will do often with math is factor expressions with variables. So let's take an expression. What if we had 20x squared minus 36xy? Okay. You might have to factor that out, especially if you're going to start solving equations. This is down the road a little bit, but it's helpful to sort of see that's where it's going. So I'm going to find the GCF of these two. 20x squared and 36xy. I'm going to do the cake method for this. I'm going to take out the variable first. So x squared, remember that means x times x. So we have an x here, we have two x's here, because they're squared x times x, and we have an xy here. So we're going to take out x first. If I take out an x here, I still have 1 left, so I'm going to have 20x. If I take out this x here, if I divide it by x, I'm just left with 36y. Then I can keep going. I have no more variables in both, so I'm going to start taking out the numbers. So I can take out 2, that gives me 10x and 18y. I can take out another 2, that gives me 5x and 9y, and at this point I can't factor anything out. So this is my GCF. Okay, so my GCF right here would be x times 2 times 2, or 4x is the GCF. Okay, so then I'm going to use the same format. Okay, we were dividing by that. Now, if we're using birthday cake, again, it's easy to figure out what that's going to equal. So we have 4x on the outside, and then 5x, because 20x squared divided by 4x is 5x. This was subtraction, so I'm going to put a subtraction symbol. And then 36xy divided by 4x is 9y. And we are done, and that is how it works. So you can use this method with the cake method, and that finds your GCF, and the cake method leaves you with the numbers. Pretty straightforward. Alternatively, let's say you were doing a problem like this one, and you did the factor trees. You can also use that, but what's going to be left, that 8 comes from the numbers that are still here. 2 times 2 times 2. Okay, or that 5, you see the 5 is not looped, so that could go right there. Or you could always just divide. Think of you're dividing that first number by 6 and that second number by 6. All right, good luck.